Hi everyone, and welcome to our video on the definition and determination of pH. In this lesson, we will be focusing on how to define pH. We're going to be looking at strong acids, and then we're going to finish off by calculating pH. Make sure you check out the description below because I've added some helpful links, including access to lesson resources via Google Drive and information on how you can join our upcoming live sessions. So let's get started. First of all, having a look at the specification. These are the spec points that we will be covering in today's lesson, and these are the points which you need to know for the AQA exam. So starting off with pH. Now there's a simple formula to calculate pH, and that's this. We use this formula to calculate pH. And this part over here is basically representing the hydrogen ion concentration. So we've got the hydrogen ion concentration. Okay. Now, as you can see, this is not like a normal formula. It's like a logarithmic formula. It has a log in it. And the reason why we use this logarithmic scale is because the hydrogen ions in aqueous solutions covers a really wide range. You can have very little hydrogen ions and you can have too many hydrogen ions. It's over a wide range of values. So we in order to simplify it and have sort of smaller distinct numbers to deal with, we use this logarithmic scale. Okay, and H plus is the concentration of hydrogen ions in solution. And here's a really important exam point. The pH values should always be given to 2 decimal places in exams, and they normally have a mark for this, so make sure you give your answer to 2 decimal places because you don't want to lose a silly mark after you've done all the hard work. Okay, now if we look at stronger acids, this is the definition, and you should have come across this at GCSE as well. Strong acids completely dissociate in solution. Okay, and you can have 2 categories of acids that you need to know at A level. So you've got a monoprotic acid and you've got a diprotic acid. Now, a monoprotic acid is something like HCl. And the reason why I'm saying this is monoprotic is because there's only one hydrogen ion in this. HNO3 nitric acid. There's only one hydrogen ion in these compounds, and that's what a monoprotic acid is. It can only donate 1 proton. So in our last video, we looked at Bronsted-Lowry acids and Bronsted-Lowry bases. A monoprotic acid can only donate 1 proton or hydrogen ion per molecule in a chemical reaction. Okay, now a diprotic acid, key that di, and we've got mono here. A diprotic acid can donate 2 protons per molecule, and the prime example of this is sulfuric acid. We've got H2SO4, we've got 2 next to the H. That tells you that there are 2 protons per sulfuric acid, and this is a diprotic acid. Reason why is because it can donate 2 of those hydrogen ions in a chemical reaction. Now, this will make more sense when we come on to some examples, but for a monoprotic acid, the H plus concentration is just the concentration of the acid. Okay, so for example, if I said to you that we had 0.2 mole per dm cubed of HCl, because that's a concentration, in the formula that we originally had, which was negative log base 10 of H plus, and that gives you the pH. The H plus concentration is just going to be 0.2. So we would substitute in minus log base 10, 0.2 in order to work out the pH. And this is for HCl because HCl is a monoprotic acid. There's only one hydrogen ion. For diprotic acids, we will have to multiply the concentration of the acid by 2. For example, if I had 0.2 mole per dm cubed of H2SO4 and we were asked to work out the pH, then in this case, what we would do is, because this is a diprotic acid, there's a 2 over here, we would need to multiply this by 2. Okay, so we would type into our formula minus log base 10, 0.4. Okay, and then the answer that this gives us will be the pH. Okay, but again, we will be looking at some examples with monoprotic and diprotic acids. Just for now, if you want a key definition over here, in terms of calculations, the hydrogen ion concentration for a diprotic acid, you will need to multiply by 2, whereas for a monoprotic acid, you will have to keep the same. It will just stay the same. Now, how do logarithm functions actually work? So using this formula, we can actually derive the other formula. Okay, so the definition of pH is basically, we've got pH equals negative log base 10 of the hydrogen ions. Okay, now what does this actually mean? If we wanted to work out the hydrogen concentration, you can actually just learn this formula, but you can also derive it from the original formula. Okay, what this actually means is 10 to the power of pH equals negative hydrogen ion concentration. Okay, and if you do maths, this will make sense. And because there's a negative there, we're going to bring this negative up here, and we would have 10 to the power of negative pH equals the hydrogen ion concentration. Okay, what we've just done there, basically any number in a logarithmic function that's at the bottom there, that's basically your base number, 10. And then it's to the power of your answer. So the answer is pH, so it's to the power of the answer. And then because there's a negative in the expression, we just add a negative before the pH, and then that will be equal to the hydrogen ion concentration. Okay, so essentially you can learn this one and then derive this one, but again, I would just learn both of them because they're not that difficult to learn. Okay, so you can work out pH and the hydrogen ion concentration from that formula. Now, to finish off, we're going to have a look at some examples. Okay, so I've got some examples over here. We need to calculate the pH and then the concentration of the following acids. So if we start off by calculating the pH of the following solutions, we've got 0.2 mole per dm cubed of HCl. Now, first of all, as you can see, this is a monoprotic acid. So we've got a monoprotic acid. That means the concentration is just going to stay the same. Okay, so we're going to have our expression, which is minus log base 10. And then it's H plus, remember. The H plus concentration will just be the same as this. So it's just going to be 0.2. Okay, and then you can use a calculator and type this into the calculator. And remember, pH should always be quoted to 2 decimal places. So we've got negative log base 10 of 0.2, and that gives us 0.70 to 2 decimal places. Okay, now for this next question, we've got 0.05 mole per dm cubed of nitric acid. Now again, over here, we've got a monoprotic acid. Because we have a monoprotic acid, the concentration is going to stay the same for the hydrogen ions. So we can use our expression, negative log base 10 of 0.05 this time. And we can type this into our calculator. And that gives you an answer of 1.30 to 2 decimal places. Okay. Now, for the last one on calculating pH, we can see that it's sulfuric acid and there are 2 hydrogens. So this is going to be a diprotic acid. Because it's a diprotic acid, what we're going to do is we're going to multiply the concentration of this acid by 2. Okay, so we're going to do 0.04 multiplied by 2. That's going to give us 0.08. Okay, now that's our hydrogen ion concentration. Okay, and we're going to type this into our log expression. So minus log base 10 of 0.08. And if we type that in, we get an answer of 1.10 to 2 decimal places. Okay, so those are our 3 answers there for calculating pH. Okay, now we're going to go on to calculate the concentration of the following acids. So let's start off with HCl with a pH of 3.55. So just memorize the equation. As I said, H plus concentration equals 10 to the negative pH. So we've got over here, we've got our expression, which is 10 to the power of negative pH. And the pH is 3.55. So all we're going to do is we're going to substitute this into the expression. And that's what we're going to type into our calculator. 10 to the power of minus 3.55. And that's going to give you an answer of 2.82 times 10 to the power of negative 4. So 2.82 times 10 to the power of negative 4. Okay, now this is the concentration of the hydrogen ions. The concentration of the acid is going to be the same as the concentration of the hydrogen ions because it's a monoprotic acid. So this is the concentration of the hydrogen ions. Therefore, the concentration of the acid is also going to be equal to 2.82 times 10 to the power of negative 4. The reason why is because it's a monoprotic acid. Okay. Now, final question over here. Again, we're going to use our same expression because we're calculating the concentration. 10 to the power of negative pH. In this case, the pH is 1.70. So we're going to have 10 to the power of negative 1.70. And that's going to give you an answer of 1.70. 0.0200. So 0.0200. And this is the concentration of hydrogen ions. Now, because over here we have a diprotic acid, this is diprotic, that means the hydrogen ion concentration that we have over here is actually double what the concentration of the acid is. So over here, we can see that the concentration of the acid H2SO4 is going to be half of that, which is going to be 0.0100. Now, if you have a look at this, it will make sense because we've had a look at some calculating the pH and some at calculating the concentration. But the reason over here, we found out the concentration of the hydrogen ions is 0.0200. And because it's a diprotic acid, that means that we would have doubled the concentration of the acid in the first place anyway, because we had 2 hydrogen ions. Therefore, to work out the original concentration of the acid, we would have to half this value, and that would get us 0.0100. Okay, and that's it for this video. If you have any questions, feel free to drop them in the comments below. Don't forget to check the description for any useful resources and to sign up to our live sessions. If you'd like to support us, you can buy us a coffee using the link in the description. Thanks so much for watching, and I hope to see you in the next video.